Hello, my name is Aiden Udan Dunstan, and my matric number is 97977, and I am from Subgroup 7, Group 2.
Hi, my name is Asma Draman, and my matric number is 98267.
Hello, my name is Deirdre Ayen, anak Judas, with the matric number of 98698.
Hello, my name is Edna Alicia, anak Chimiam, with the matric number of 98765. The objective of this experiment are to investigate the physical properties of different lipid-containing substances, including their appearance, odor, and solubility. It also aims to examine how these lipids behave in polar solvents like water and non-polar solvents such as toluene. Lastly, the experiment explores why lipids are grouped together based on their common physical and chemical characteristics.
Two sets of three separate microcentrifuge tubes were prepared. 5 drops or small amount of solids were added into the microcentrifuge, where the samples are in the first set, solubility in polar solvent, where 1 ml of distilled water was added to each centrifuge tube. The tubes are capped and shaken to mix. For the second set, solubility in non-polar solvent, where 0.5 ml of toluene were added to each sample. The tubes are capped and shaken to mix. The appearance and smell of the sample in the microcentrifuge tube were all observed and recorded. The appearance of lipid mixed with polar and non-polar solvent shown as the following.
In conclusion, this experiment successfully examined the physical properties of shortening, ghee, and olive oil. All three lipids were insoluble in water but fully soluble in toluene, confirming their hydrophobic nature and the principle that non-polar solvents dissolve non-polar substances. Their separation and floating in water illustrate their lower density and immiscibility. Differences in odor and appearance, such as the natural pigments in olive oil and variations in saturation, reflect their unique compositions. These results highlight the relevance of understanding lipid behavior in food processing, nutrition, and product development. Overall, this practical reinforces key biochemical concepts like polarity, miscibility, and how molecular structure affects physical characteristics.
In the new learning section, we can say that we learn a lot from practical 3. First, we learn about solubility and how it relates to polarity. Lipids are non-polar substances, so they dissolve well in non-polar solvents like toluene, but not in polar solvents like water. This helps us understand why the lipids stay as separate layers in water but form uniform mixtures in toluene. Next, we saw how saturation and physical state of lipids can affect solubility. Solid lipids like ghee and shortening floated on water because of their low density and solid form, but they fully dissolve in toluene. This showed us that lipids' texture and structure influence how it interacts with different solvents. Another interesting thing we notice is how the choice of solvent affects smell. In water, we could still detect the original smell of the lipids, especially ghee and olive oil. But in toluene, the strong chemical odor mostly covered them up. This taught us that polar solvents may preserve their natural scent better than non-polar ones. Finally, this experiment reminded us the importance of careful observation in biochemistry. By paying attention to details like color, texture, and smell, we were able to connect physical properties to the chemical nature of each lipid. These kinds of observations are useful when identifying or classifying unknown substances.
Subjective observation. Describing appearance and smell depended on individual perception, which could vary between group members and affect the consistency of the recorded results. Volatility of toluene. Handling toluene was challenging because of its strong odor and volatility, requiring extra care to avoid inhalation and spills while ensuring accurate measurements. We need to use a wider range of solvents. This is for test the lipid samples with more solvents of varying polarity, such as ethanol, hexane, to compare solubility more comprehensively. This will give a clearer understanding of how lipid solubility changes across different solvent polarities. As for the use standardized excitation, shake or stir the samples using a mechanical shaker at a consistent speed and duration to ensure more uniform mixing, making results more repeatable and comparable.
Other suggestions for improvement in this experiment would be use temperature controlled conditions. Maintaining a consistent temperature during solubility testing could improve the accuracy of observations. Some lipids might dissolve better at slightly elevated temperatures, especially solids like shortening and ghee. Next would be record changes over time to observe stability. Tracking how the appearance or separation of mixtures changes over several minutes could provide insight into emulsion stability or delayed solubility effects, especially for lipids that showed mild emulsification in water.